something. So yeah, okay. So we you should write this down. You should maybe even get out your notes, because and this is another one of those bridges that I hadn't intended to cross, but we arrived at the bridge and now it's time to just cross it. So quick notes, super quick notes. And I'll keep the recording going after this so that if you guys want to, bless you, if you guys want to go over more questions, we totally can. I'd be happy to help. There's a lot going on with these. These are not simple math problems. Just so if you feel like it's a lot, that's normal. Anyways, there's something that I have to show you how to do, and it sounds really fancy, but it's not very fancy, but we have to call it what it is. So there's a skill that it was like yesterday, like solving those little short quadratics with that cool new way. I just kind of, it was organic in the moment. I realized we needed to learn it. So we learned it. And today I realize now you need to learn how to do this. So this becomes part of our toolbox today. Sounds really fancy. But what it really means is this. It means, well, here, let me get rid of those two letters. Actually, I'm going to make this a little more generalized. Roots are not allowed in the denominator. And yesterday, when I was conjuring up your examples, I kept giving you problems that had numbers in the bottom like 4 and 9. And so we didn't have to worry about this, because the roots that we would have gotten when we took the square roots of fractions, the roots we would have gotten in the bottom, they were just getting rid of themselves, right? Square root of 4 is like, boom, I'm 2, like easy peasy. Right away, if things go correctly in problem 1, at the end, you should be taking the square root of a fraction that has a 5 on the bottom. So I'll go through the problem again in its entirety if you would like, but I just wanted to show you, and we'll do like 3 or 4 examples of this. Just, it shouldn't take long. It's a very simple concept, but this becomes a part of what we just call in math simplifying. Like in the same way that people say, you get to the end of an algebra equation, say, should I reduce the fraction? Of course you should reduce the fraction. Like, there are things in math that we just always do. This becomes one of them. So at the end of the first problem, and I'll show you this again in a bit, you wind up with x squared equals 2/5. And if you've already made it to the end of problem 1, then you know what I'm talking about. If you haven't, you'll get there. And again, yesterday when I was writing your examples, I kept making sure that that bottom number was a friendly guy, like a 4 or a 9. So when we rooted it, the problem didn't exist. But here the problem does exist. So what we learned yesterday is that if we square root both sides of this little white equation, we get x equals positive negative, right? And then we take the square root of the top, which doesn't bother us at all. And then we take the square root of the bottom, which does bother us at all. Square roots, I wrote it in red for you. Square roots are not allowed to be left in the bottoms of fractions. It's just a mathematical thing. So the reason we call this rationalizing is because square roots are irrational. Like the square root of 4 is not irrational because it equals 2. But the square root of 3 or the square root of 2 or the square root of 5, any number that cannot be square rooted is called an irrational number. So the goal of rationalizing the denominator is just to fix the bottom. And it's actually really simple to do. It's you don't change the value of the answer, but you change like the acceptability of it. So what we're going to do is we're going to essentially murder off that square root on the bottom. You learned back in 4th grade, someone taught you that you can do whatever you want to a fraction, provided that if you multiply the top or the bottom, you have to do the same to the top or the bottom, right? So it stands to reason, I think, and I'll give this a second to set in. Would you agree if I multiplied by the square root of 5 that I would get something good? And if you don't, that's okay. I'll kind of walk you through this. But what is the square root of 5 times the square root of 5? It's the square root of 5 times 5, which is, these collectively make the square root of 5 times 5, which is the square root of 25. But what's the square root of 25? 5. We just rationalized the denominator, and all we had to do was multiply it by a carbon copy of itself. And you don't have to even do the math. What you learn about this is that the arrival at the square root of 25 is unnecessary. If I had, like, for example, the square root of x, and I multiplied it by another square root of x, what do I get? Cut out the middleman. What do I get? I just get x. I don't ever have to go to x squared, because the square root of something times the square root of the same something is just the something. If you wanted to make it take longer, yes, you could multiply those two roots together and say it's the square root of x squared. But think about how silly that is, because what's the square root of x squared? Well, it's just x. What's the square root of a little happy face times the square root of a little happy face? It's just the little happy face. What's the square root of a times the square root of a? It's just a. That's how square roots work, is if you multiply a square root by a carbon copy of himself, you essentially cancel out the root and get just what's inside. It's a great trick to have in your back pocket, because now anytime I don't like a square root in a certain place, I can just multiply it. I can unalive it essentially by just multiplying it by itself. Now, if I multiply the bottom of this fraction right over here by the square root of 5, we also have to multiply the top by the square root of 5. Correct? Now, this leads us to our answer. Our answer is going to be positive or negative root 10 over what? Done. That is how you rationalize a denominator. Whenever you get an answer that has a square root in the bottom, it's okay. All hope is not lost. You multiply the top and the bottom by the root that you're trying to kill, and then it goes away. Let's practice just that skill, not even in the context of what we're doing. Let's say I got to the end of a problem and I got the square root of 6 over the square root of 3. We're not scared, right? It's not okay. We understand that that's not okay. And I'll show you that there's a shortcut way we can use that sometimes works and sometimes doesn't. What would I do to rationalize this denominator? I would multiply by exactly a carbon copy of the root that's causing me stress. So I'm going to multiply the top and the bottom by the square root of 3. And if you say, why is that legal? Well, it's because the square root of 3 over the square root of 3 just equals 1. That's why all this magic has always worked, is because we're not really multiplying by anything other than just 1. We're just giving it a creative sort of twist. What do we get on top? Yes, we do. We get the square root of 18. And what do we get on bottom? 3. Now, this problem poses an extra challenge because the square root on top is not simplified. There's meat on that bone. How do you break down a square root of 18? Yes. So if I use a 9 and a 2, this isn't anything new. You've done this 100 times. Breaking down a square root is commonplace for us. What's the square root of 9? 3. So I have 3 roots of 2 over 3. And then, of course, what would I do? Simplify. I would cancel these 3's because why not, right? We've been doing that since we were like 10, reducing fractions. What's the final answer? Now I'm going to write this over here and I'm going to see if you can connect some dots. Can you see how we could have saved all of this work in this particular instance? Do you know how square roots can be multiplied together? Like if I gave you the square root of 3 times the square root of 5, what is the answer to that? Stop saying just the number, the square root of 15, right? It's okay. But in the same way that square roots can be multiplied to get a square roots can also be divided. And so if you think about it, look at this problem over here. I'm going to circle them in yellow. The square root of 6 divided by the square root of 3 is just the square root of 6 divided by 3. Done. The trouble comes with things when that doesn't work, right? If I gave you the square root of 10 divided by the square root of 6, we can't use this trick, right? Because 10 is not divisible by 6. So what would I multiply both the top and the bottom by here? This will be my last example. I know you're starting to get back to your assignments and you're done listening, some of you, but you probably just should give me another minute or so. What do I multiply the top and the bottom by? Root 6, because that's the root that I'm trying to fix, right? And what do I get on the bottom? What do I get on the top? And once again, I'm faced with a situation where I have to simplify a root. So the top I would break into two roots. The bottom would stay as 6. What are the two roots on top? 60 has a buttload of factors, 2, 33, 26, 10. But the one I'm looking for, I haven't said yet. What is it? Yeah, that's my guy, 4 and 15. So this becomes 2 roots of 15 over 6. And then I would reduce the 2 and the 6, of course, like a fourth grader would, down to a 1 and a 3. So my answer here would be root 15 over 3. Please feel free to continue to ask about that, because I know that that's a lot to just throw at you. It's not a difficult skill once you understand that it's just, you're not doing anything massive, but it can be a little bit much. So would anyone like any help while I've got this recording going with question 1, or are we good? Okay, well, I'll keep it going. I'm just going to pause it. If you have questions, again, I cannot read your minds. If you don't ask, I'll assume you are doing fine. Yeah, that's kind of a big part of it, eh? The synthetic division. So number 2, if anyone's interested, I am through 4 problems and I have not found a starting GCF yet. There are GCFs later in the problems that you got to get out or should get out, but like problem 2, you look at it and all those numbers can't be divided. So let's hop right in and see if we can figure out what you're doing wrong. So we have 10, negative 13, positive 17, negative 26, and negative 6. And then we're going to synthetically substitute the given number, which in this case is negative 1 over 5. So let's try to diagnose your issue here. Get this nipped in the bud. Yeah. We're going to drop the 10. Now, do you know what negative 1/5 times 10 is?
I just calculate.
Okay, so the way you do this is, and because I mean, you could use a calculator, but I don't think that's any way to do this because I think you're always going to be slower. So the way I see it is, I'm going to write this in green for you, is I do it as negative 1/5 times 10. Now, I don't even really think of the negative just because like I already know going into this, and you do too. You know going into this that because the red number is negative and the white number is positive, that we could just already know the answer is negative, correct? Are you sure?
Is it just because there's negative?
Yeah, it's just look up here at the board for a second. Don't look down. If this is what we're multiplying, correct? And you've known for years that a negative times a positive is a negative. So that's all it is. Just keep that part of it simple. If the white number was also negative, then it would come out positive. But I say, let's get that out of our thoughts so we don't have to burden ourselves with like, where does the negative go and all that garbage. So the way you do this, and your brain can do this really quickly if you just let it practice, is watch my pen, make a hook. And when you follow that hook, you just divide on your way down and multiply on your way up. So what's 10 divided by 5? 2 times 1. 2 times 1. So we now know the answer to that is negative 2. Okay, let's practice again. The more we practice this, eventually you'll be so quick at it, you won't even think about it. You okay? Uh-oh, that's from the yellow hook. 10, hold on, stop, listen. Follow the hook. 10 divided by 5 times 1. 2 times 1. Got it? Okay, that's the process you're going to do every single time is divide and multiply, divide and multiply. So when we add these two numbers together, we get negative 15, and now we get to practice again. And as I show you my work up here, again, I'm not going to spend time with negatives. You know, and I know that a negative times a negative is a positive. So to heck with the stupid negatives. We're just going to do 1/5 times 15. Do the hook again. Correct. 3 times 1 is 3. So we stick a 3 right here, and we're on our way to step 4. 17 plus 3 is 20. We start again. So your brain just keeps doing this little hook pattern over and over again. And so if I do 1/5 and 20, then the 20 and the 5 divide. What do we get?
4.
Yes, and 4 times 1 is 4. I just want to make sure I put -4. And that's where just big picture, you look at the problem and just, you know, it's negative. And then the math and the determining if it's positive and negative is sort of different from the math. They're separate sort of ideas. And then you add those together and you get -30 and rinse and repeat. Like we just keep doing this over and over again. You'll have to do this process probably like 40 times on this worksheet. So you want to be super quick and good at it. Does that make sense? Okay. And eventually I do see you writing it down, and you should continue to write it down, and you'll find probably within the next 10 minutes that you just don't need to anymore. You'll start to just see the divide multiply hook. Does that help? Okay. Does anyone want me to go through problem 2 any further? All right, I'll pause it here. If you decide you want more help on that problem, I'll just keep it right here. And we're back. So if anyone would like to come along for the ride, this is the actual completion of problem 2. So continuing on with the old fish hook, we're going to get a 6 here and get a 0 here. And then I'm going to identify that all of those numbers in that row can and really, 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 really should be divided by 5. So that's going to make our lives a lot easier going forward. It's not the end of the world if you don't, because grouping will still work, but it's just easier to work with smaller numbers. So when we divide them all by 5, this one becomes a 2, and it's 2x to the third. This one becomes a -3, and he's my x to the second. And this one becomes 4, and he's my x. And then the 30 becomes, the -30 becomes a -6. You with me so far? So there's going to be grouping here. And to solve this by grouping, we've done this 100 times. We just draw our little wall and begin. 4-term polynomials are going to be, grouping is our go-to at this point. So what can we get out of the first half? These guys. That's the best we're going to do. Right. And what does that leave behind? Yeah. I mean, nothing changes. We're just taking X's out of them. No signs change, no numbers change. That's all. Then we copy down the sign after the wall, always, which is a plus. And then what can you take out of 4x and 6? 2, which leaves behind what? 2x minus 3. Since we're dividing both of them by 2, then we go, bam, look, it worked. So our yellows come together to form a factor. And our whites GCF themselves out to become the other factor. And we have those two factors. Are you with me so far? Okay. Now, what we learned at the beginning of class yesterday, this is where that comes in handy, is remember, I need to set each factor equal to 0. So if I set the yellow one equal to 0, and I solve this little baby quadratic, what would I need to do first? You bet. So we're going to get x squared equals -2. And then we have to take the square root of both sides. That's the sort of finishing part of the process. And so when I take the square root of both sides, I just always write x equals positive, negative, and then I go and I do the math. So we have to think about and talk about this. Like, first, what strikes you about the square root we're about to take? So we know there's going to be an I. And what can you do with the square root of 2?
I don't know.
Well, the answer is the reason you don't know is because nothing. I mean, if it was like a square root of 8, at least I could break it down using a little tree or something exciting. But 2 is just like the ultimate garbage root. So from this yellow factor, I just get x equals positive negative I times the square root of 2. We always put our i's before our roots. And then you say, well, there's supposed to be 4 answers. Well, we're about now to pluck them all out and bring them all down. From this one, we get another root or 0, whatever you want to call it, which equals 3/2. And then we also get our 4th one now from the very beginning. The very beginning, we had a freebie that was -1/5. And I'm going to make little check marks just to show you how many answers we have. There's 1, 2 from there, 3, 4. Got it?
Yeah.
All right. I will probably not give you another full work day on this tomorrow. I'm going to kind of see what's in order here. I'd recommend that you get some problems done. I don't know where you are in the process. But I listen, if you're on like number 6 or 5, I'd say you're probably in good shape. Take the day off. If you're back on 2 or 3 or something like that, I'd say probably get a few done.
Are you gonna, did you do the questions finished?
No, but I'm on. I'll get the answer key posted today sometime. I'm on like number 6, I think.